One of the things I forgot to do, since I'm the rookie, is to ask if there were any announcements of future robotics events. And so, Greg.
Hello everyone, I'm Greg Maxwell, and I've been kind of running the Max group with 18 other members of the SV ROS. And one of the things we wanted to do to kind of build off of what we've learned is to share it with the rest of the people, or whoever is interested. So we are starting a series of training classes about ROS. And we're going to take what we've built with the brainstem computer and what we've learned with Max and try to share it with other people who want to use ROS in their robots. So you saw Max out running around, and we really want to pass this information on. What we did in the competition is we have a brainstem controller that's completely ROS. We made a relay control system that did a whole bunch of signaling that was another computer doing ROS. And then we had a lot of Arduino serial communications that were working with sensors, the Dynamixels, pan and tilt controllers. We had an RDF that would basically allow it to find home. We had a solar compass. We also had a power supply. We had all different things, that were basically messaging ROS, and we want to share it with you guys. And one of the things you saw today working was the AR vision targeting, allowing this to be autonomously able to find its way home. These are things you can learn if you want to join us. The main part that we're going to try to teach is the brainstem, which is the basically motherboard, RoboClaw motor controller, encoders, motors, and then basically all the ROS that's in here that makes it actually work and give you a full understanding of how that ROS is put together and how you use it and how you can use all the tools that ROS has. And this will be basically done, we're hoping you'll get a basics within 4 months. We don't know if we'll have 8 to 12 months worth of sessions, but it's very possible as people learn and want more information, we'll have specific classes on or sessions on certain topics of ROS. It's not something you have to attend. We're going to have monthly meetings where we're going to try to present everything. But we're trying to make sure everything's online. The tutorials and help, all the code, all the stuff is available for you to use and learn. All right? And one of the goals is that if you wanted to, you could take a Raspberry Pi, a BeagleBone Black, the Jetson that we're using here, a RoboClaw motor controller, supply your motors, supply some encoders, give it some battery, and you could have your own robot running ROS. And we'll assist you and help you make that kind of happen. We can't really make robots for everybody because that would distract from the ROS message of what we're trying to do, but that's what the goal is. And then if you're interested, the easiest way to find us is just to search for SV-ROS. We have a meetup. There is a $6 monthly dues that are part of this to help cover the cost of having the Hacker Dojo and some of the systems to maintain the code and everything. So we look forward to seeing you, and anyone who's interested in ROS, it should be a fairly, I think, sustainable way of learning it and sticking to it. Thank you.
Thank you. For our panel discussion, we have Greg, who just introduced himself. We have Chuck Pitzer, head of team Ghost Raptor from Brew Robotics, who reached the semifinals with a pretty terrific robot. And we also have Ed Martini, that's right, from Team ARG, another, what?
Fast Eddie.
Fast Eddie.
Fast Eddie.
Okay. Team ARG also had a very good run at the NASA Centennial Challenge. So the format of it is I have some pre-entered questions, and you can take them in any order, or you can decline to answer the question. But the first question to all our participants is, how did you get started in robotics?
Better not start with me. I have to think about it.
Wow. I'll start. So I think robotics didn't quite have the same look and feel it has now. Now there's the do-it-yourselfer movement. When I first got started in robotics, there was none of that. There was, I think the first book I read on robotics was Robot Builder's Bonanza. Anybody heard of that?
Mm-hmm.
Yeah. Exactly. And it was one of those things where I had no idea what I was doing. I was a mechanical guy, and even then I wasn't even a good mechanical guy. I was, in school, and I was looking for a way to express what I knew was kind of innate. I just wanted to build something that had, mechanical, some kind of physical piece to it. And then I also wanted to build some intelligence into it. And that was the first avenue I had, was to see Ian McComb's Robot Builder's Bonanza. I think after that, the things that really grabbed my attention were things like MIT. They used to have these competitions on TV, and some of you might remember, like, they would have these devices, and now they weren't necessarily robots, but they were similar to like some kind of intelligent machine that would put ping pong balls into a little hopper. That fascinated me, and the part that really fascinated me was the competition aspect, because it was just really intriguing to be able to have to think quickly to come up with a solution to these problems, and then compete against somebody else. So, I mean, I think in a lot of ways that's what drives innovation. I see it every day, and I think that's how it started. And then of course, as soon as I saw Robot Wars, the US version, which was 94, 95, 96, they canceled the 97. But as soon as I saw that on TV for the first time, I was hooked. I knew I wanted to be a part of that. So, I mean, and it could go even further back to Star Wars, and I think we're all exposed to that. But I think those were the kind of the key elements for me in the beginning, was just those exposures.
Ed?
I'm totally ready now. I got thought now. As a kid, I worked on my own bicycle. I did that a lot. Chains, sprockets, hubs, taking things apart and losing all the little balls on the ground and having to find them and put the grease back in. My grandparents both worked at a telephone company, so we had a never-ending supply of telephone parts. So we ran our own telephones to the tree house and stuff. So there was mechanical side, wiring side. When I went to Cal Poly, I saw an HP pen plotter for the first time, and that was fascinating to me. I worked at Edwards Air Force Base where they had an HP pen plotter, and I had the opportunity to do a project using the pen plotter. So that was kind of my first programming something that mechanically moved by itself, and that was very satisfying to me. I was into RC cars, so all these things just kind of come together, and got my first Lego robotics kit, the very first one, the Mindstorms. And
the yellow brick.
Yep, the yellow brick. And I actually dusted off my yellow brick the other day, and I kind of started to get it working. You have to have a really old computer to use it. So I still have the idea that I want to do a table bot that uses the original Mindstorm, not only the Mindstorm brick, but the original Mindstorm drag and drop programming language. I have to find somebody who will give me an old laptop that has a serial port and will, an XP. I think it's XP.
Get a copy of Windows like 95
Go to
or
weird
XP.
stuff.
XP.
Run it in a VM.
Yeah, it's hard. Yeah.
VirtualBox.
Yeah.
VirtualBox.
USB adapters.
Yeah, I was there. I tried that. It's a long story. Not that long of a story. It was one whole day. It took me one whole day.
You need the infrared program.
I actually got the infrared to work, and then it wouldn't, my brick wouldn't respond with the infrared programmed program. We can talk about it.
Yeah, we can do that offline.
Yeah.
Great.
And now I work at Nito Robotics, so
Yeah.
now I'm a pro.
Well, we're always skeptical because Camp works at
I've always been like a do-it-yourselfer, so I've had RC cars, RC airplanes, just soldered up radios. I made my first Heathkit computer, way back in the day. What really got me going was the vision side of stuff. I had a career in basically vision for security purposes, selling CCTV cameras and memory systems and evaluating images and was kind of into that side of it. And then I went to San Diego where they have the RoboSub competitions, and I saw these colleges from around the world. There was, I think, 14 of them. And they were trying to basically do autonomously find things underwater, shoot torpedoes, rise up within an octagon, and they were having trouble just getting the robots not to flood. And it was interesting. I started working with organizers, seeing how we could make like an open platform for the subs, so that you wouldn't spend all your time worrying about flooding and power and cooling, which were the common problems of these things not working. Plus, they weren't very good at lighting because the water would be murky and it'd be overcast and everything would stop working. So that was kind of my start in all this stuff. And then I got basically moved up here because of a job, and so I'm now doing this. And it's basically a hobby that's kind of muck. Running this Max, it's taken over my life.
So these big events like NASA SSR and BattleBots require a team. How do you put a good team together?
Big. Actually, it wasn't hard. For us, I have the SV ROS group, so I just presented to the membership of the ROS group. We have signed up 197 members. Of those, 18 people joined the group, and they all brought different skills and different sets. So it really wasn't hard to get the group. What happens, though, is it's hard to maintain their energy through the whole problem set until the end. So it's kind of an organizational challenge.
Why? I'm going to kind of steal some of Ed's thunder here, because I was involved in both these projects, and I think this one's actually a better story than this one. It was back in December, and December 2014, not December 2013 or 2012, but it was actually just a few short months ago. And we were all sitting over at the Aloft bar, and Hans, where's Hans? In the back there. Hans is like, I really want to do this. I really want to do this. I want to do this NASA SRC challenge. And I'm just,
SRR.
Simple Return Challenge. Oh, SRR. Okay. So, first mistake. I make many. So anyways, Hans is like, I really want to do this. And I'm like, yeah, I don't know if you want to do it. No, I'm not sure. So the only way I could figure out if they wanted to do it is, I jammed together a platform really quick. I'm like, make it work. Put something together, make it work. And my point is not necessarily to test their skills. I wasn't trying to look to see if, they could do the work right now or not right now or meet a deadline. I just wanted to know if they were emotionally involved, right? I mean, were they going to make an emotional commitment to get this thing done? Because every single one of us has a job, right? We have a full-time job, we have family, we have wives and kids and all sorts of other commitments. Are you really emotionally involved to make this happen? Because it takes a lot. And it's not just the beginning, oh, this is the fun part. It's the end when it really counts. It's oh, we're going to stay 7 nights a week, every day, till 2 a.m., working on this project. These guys were at my house every night working on this. We're stepping over each other. My garage has a walkway about that wide. They're all lined up in there around the robot, working on the robot. And I'm like walking over them, trying to get to my CNC machine that's over on the other side of the garage. But the point is the way you put together a team is you got to make sure they're emotionally committed. Otherwise, and it's especially if you get too big of a team, nobody feels committed to each other. And I think that's why we were able to actually have, a competitor, a valid competitor for, 5 months worth of work. I love this team. I'm not going to give you a hug. But we had a lot of fun, but it was really hard. But the point is you got to just make sure that you have a committed team. Otherwise, it's not going to get done.
We're just happy that your wife came back, Chuck.
Don't tell that story.
What was your biggest technical challenge?
The time. How fast we had to do it, yeah. We actually, the team was committed enough. I mean, our commitment actually, in a way, ramped up toward the end because of the way the time worked out. We didn't get started as fast as we should. And we met, and I think everybody on the team kind of agreed that, and we were meeting once a month at Hacker Dojo, once a week at Hacker Dojo. And, you know, early on, a few people started saying, well, we should meet twice a week. But of course, like Chuck said, everybody's got a job and a commute and life and a wife and, you know, all that stuff. And so toward the end, we really ramped up the commitment where we were literally working every single night, nonstop. And, you know, to the point where we went the last 5 days, there was at least 2 members of the team who didn't sleep for 2 days on 2 different times during a 5-day period. I was one of those. There's video proof of that.
Fall asleep with in a plate of French fries, right?
Kind of.
Great. You want to say what the greatest technical challenge was? Or?
It was, it's an interesting question, because this is really, the challenge, SRC was a software challenge. It was to basically have a vision system to find an object, and we didn't have a base. So hardware and getting something that could do that was much more involved than I expected. You know, the software kind of came along, and it was now getting the software to work on a platform that could carry it around. So we had all these pieces that kind of came at the end, and all of a sudden it got bigger and bigger and heavier, and it was hardware. It was surprising, even though it was a software problem. We actually had, the technical side was getting a robot that can run and carry the weight, and as we had more stuff, things changed. It didn't turn well, so we had to figure out things like that. So it was actually more mechanical than anything else.
And I'll say the director of the Sample Return Challenge, he feels like it should be more of a software challenge than, I heard discussions there that at one time they wanted to standardize on a robot platform so that everybody had to use the same one, to make it so that it was more of a software challenge and an algorithms challenge. Instead of pretty much like on the first day, out of 14 teams that were there, 11 teams qualified to go into level 1, and only 3 teams made it off the base.
Off the base. They're all asking, will you make it off the base? It's like, well, why wouldn't we? Little do we know.
All you gotta do is
For the
drive
first
on the
time
base,
ever, why
right?
wouldn't it get off the
That's
base?
easy.
And then all of a sudden it's showtime. It's like, oh wow, this is going to be tough. Yeah, but it definitely, it's interesting to see there was hardware. That's why I think, you know, trying to present this common brainstem and trying to get simpler hardware so that part isn't a worry, just, you know, will make it easier for people to start doing vision stuff where the actual work needs to be done in robotics.
This question may have been answered already somewhat, but what in the logistics of competition is the biggest hurdle? Is it just time management, or what are the logistic hurdles?
Having a single robot, right? I mean, if we had a way to have each team member have access to their own robot, which is, you know, kind of a fantasy, it's never going to happen. But we had one robot, so like Chuck said, we literally had to gather around the robot in camp chairs in the middle of the night, and, you know, with the garage door open, and everybody trying to program. I mean, there would be, you know, we have this tray, and you can see the tray is covering a lot of the equipment underneath. So if that tray motor doesn't work, if there's something wrong with the tray motor, you literally can't get to the wiring underneath. We have to move the tray, guys. And everybody would say, oh, well, the tray doesn't work right now, so you have to wait.
We got to wait 2 hours.
And so, yeah, so then you sit there and drink a beer and wait. And then eventually you get the tray to move, and now the tray's out. Well, when the tray's out, the manipulator...
And the longer the wait, the more beer,
The less gets done eventually.
We did learn very early on that you can't use strong beer. You have to use what I call daytime beer. You can't use nighttime beer. Well, when the tray's out, then you can't run the manipulator on because the tray's in the way. So there's software interlocks for that. But there's a little logistical nightmare just in the design of the robot, which on the field it all works great. But when you're trying to get to all these things at the same time, 6 team members all around doing stuff, it was interesting.
Well, I know that one of the problems that Max Stout had is the robot did not arrive when it was supposed to arrive. We only had just a couple of minutes.
One day.
One
It
day.
said everyone had like 2
ready.
days to put it together. We have 1. So that can be kind of added stress.
We had 4, actually.
Yeah.
We arrived on Friday,
Yeah.
because our robot was there waiting for us, so
Yeah.
we had a pretty luxurious time.
Yeah.
And poor Chuck, who, Chuck's job was fairly well complete by the time we arrived, and then we never picked up a sample for the whole 4 days. He was pulling his hair out.
Yeah.
Let's take more ROS bags.
Yeah. ROS bags were
ROS
quite a sore subject.
Yeah. Oh, we had a wonderful discussion about the drawer too, because you're supposed to pick up samples and keep them separated, and it got to be like, let's stop talking about the drawer. We aren't going to pick up any samples at all. Why bother about the drawer?
Well, yeah, I remember that the discussion of, and like, oh, we're going to pick up 9 samples, and I'm going, yeah, right. And I noticed you have a 10 sample drawer.
Well, no, it's not. There's 9 samples in the drawer. The 10th sample would be held in the hands if you
Okay.
were so lucky to pick up the 10th sample. And after we saw a team with the big, tall and Zoe's team, team survey, I walk up and look at their robot. I would have bet $1,000 that they would have won. I would have put $1,000 on their robot. It just looked like it was a winner. And then they drove around for 2 hours. They never bumped into anything. They never drove off the course, and they never picked up anything either.
After driving over the stuff
Yeah.
a couple of times.
They were real close to several
And the
things.
same thing with like Voyager. They were close and they could pick the stuff up, but they just didn't see it. They just didn't pick it up. And these are people who have invested, I would say, hundreds of thousands of dollars in doing this, and their vision system couldn't pick this stuff, couldn't see it. So it's a challenge. It's definitely, it's hard. That's why if we got a working base and we don't have to worry about it, we can work on vision, will be better. Mapping and vision.
What's your secret sauce?
Birds. And Steve and Ralph. The people. It's the people. When we won the Connect Challenge a year ago, the secret sauce was a product called RTAB Map, and we weren't able to incorporate it in this robot, but I think it would be secret sauce for our next robot. So, but it's the people that was the secret sauce.
Chuck, go ahead.
Well, for combat robots, what you'll see in all the successful competitors are competitors that every single one of the top competitors, except for Byteforce, had been in the game for a long time, and they had pretty much the same machine that they were running for a long time. So I would think that the secret sauce is really what you build up over time.
Consistency.
Yeah, you want to have proven platforms. As I demonstrated to the world for my first match, if you go in there with an unproven platform, sometimes it fails right away on you. The chassis I've had here for 6 years, and I've run it over and over again. It's failed lots of times, but I've gotten it to the point where I understand what's going on with it. So, I think probably one of the best things as far as the secret sauce goes is just stick with what you know, and build upon what you know. Don't start from scratch every time, because what you end up doing is finding all sorts of new problems. So if you have, technology you've developed, just build on top of it. And that's the way almost every one of my platforms has gone. This platform, actually, a lot of these pieces, at least the tracked pieces, are BattleBots. Those are all modules from an old BattleBot. That was actually a robot called Tripoltaraptor back in the early days of BattleBots. And
Sponsored by Chipotle.
Tripolta, not Chipotle.
It's giving you ideas.
But
for
that's a good
sponsorship
idea. That's a
opportunities.
great idea.
Chipotle
We should
out
use
there.
it. But so, my idea is, take pieces of what you've already proven, what works, and put it on something else and build up from that. That's the secret sauce for me.
I would say our secret sauce is education. When we look at all the little kids around here, the education, everybody's very strongly educated, and persistence. Right? There's a lot of things where we had 3, 4 tries. The little stereo camera thing. It's a very inexpensive thing, but we went through it 3, 4 times to get it right, and in the end, it works out really, really good. Same with the manipulator. bunch of the motor control stuff was very, very difficult, demeaning, and just by sticking with it, we got it to work good enough in the end.
You gotta believe. You just gotta believe it's gonna work. You gotta keep noodling at it.
Another thing is that we got the platform to actually move very early on. It was after we paid the money, though. We didn't have the platform working before we signed up.
I know. I told you it was just
Yeah.
an emotional
Yeah.
commitment thing.
Yeah. What something Chuck said, while the guys on Bike Force may have not competed in BattleBots, I know some of the guys, and two of them have been doing robotics competitions through FIRST. You know, have 30, 40 years of competition experience on a two-time national championship team. So it's not like they know
Yeah.
about robotics competition.
Well, I'm sure that machine consisted of a lot of things that they reused, but you know that was a new machine.
Yeah.
That was one of the few new machines there. Actually, most of the competitors that did really well were competitors that came either from Robo Games or from the early days of BattleBots, and that's because they kind of reused what they already knew.
What took you by surprise in the competition? What was unexpected or something you didn't anticipate?
The size of the field, you know, we kind of knew, we'd seen it in Google Maps, but when you walk up to it, it was solid 3 times as big as what I expected.
But the sample was a lot closer than we thought it was.
Yeah,
And it was a clear shot.
yeah.
Yeah, we didn't expect that.
Yeah.
That was a surprise.
We had Chuck and I had a running joke about Team 1 Arduino, because basically, you know, we felt like with just the motor drive and the wheel odometry, we could have at least driven over to where the sample was with no more brain than a single Arduino.
Yeah.
You know, of course, we couldn't have picked it up and we couldn't have returned, but we could have at least got there.
It was my first robot competition, so it was really intense getting off the platform, and we didn't get off the platform for the first time. That was, you know, it was very unexpected of how kind of the pressure and everything, trying to get it to solve work. And, the team was up pretty much 24 hours solid, trying to get all the pieces together. So we had a 10-minute window from the time we basically were given the robot to get the code in and get it launched. And then we started eating into a penalty phase, and we had another 10 minutes, and it went by like that, and we didn't get it launched. So that was probably the most intense. And the other thing was, if you looked at all the robots in the competition, where they kind of came from, it was almost like a mom and pop type operation. There was a lot of kind of, I would say, you know, everyone kind of came with their own robots and their own ideas, and it was interesting to see how each one solved the problem. A group of WPI alumni made kind of a street sweeper robot, and it went out and swept all the grass off the field. You know, so that was kind of unexpected. So.
The the team from MIT, they were the MIT Robotics Club, so they weren't like the robotics lab people or anything like that. But their robots were very sophisticated. They did a GoFundMe, and they supposedly collected $100,000 or $60,000 or something. They had these really nice four-wheel drive sub-robots that would just drive around and look for things and report back to the main robot where they were. And they looked really good, but then they had, you know, a series of kind of setbacks. And, you know, it was a little less of the mom and pop. You know, they looked really pro. And like Team Survey, I really thought Team Survey was going to take home the prize. We were all very confident that somebody was going to take home the prize. And it was very surprising to see that there was literally not a single robot that completed level 1 this year.
Yeah, I heard when I was watching the video, and when I heard the MIT robot got rained on.
Oh, and we were right there. I offered to give them our base platform just to set on top of their robot. And they said, no, we'll be okay. And we were rushing, and we had a tarp, and we were rushing, and we had the weather map, and we knew it was coming. And we actually got rained on a little bit, but they got rained on a lot.
We have only 2 more questions, and then we'll open up to the audience for questions. And if you could do one thing differently next time there's a competition, what would it be?
Don't overcommit.
Don't have any interruptions. Forget the wife, forget the family, just commit to this, stop working.
That's right. Yeah. Stop sleeping.
Stop sleeping.
There's not, I don't think
Practice,
there's
practice, practice.
one thing.
I mean, from my perspective, it's so sequence of events started with this team, and I committed to these guys, and I couldn't back out. I mean, I was going to build your robot. We're building a robot.
Here it is.
And then I get a call from BattleBots from Greg Munson, and he's like, "Hey, guess what? We're doing BattleBots. It's coming back." I'm like, "Oh, okay. It's going to be on ABC." I go, "Oh, okay." And it's going to be much bigger this time. And you know, I did 5 seasons of BattleBots before. Obviously, I'm invested emotionally. But I was hesitating when I first got the call, but I was like, man, that's the call I can't pass up. And I had to do it. I had to do it. So, and I told these guys about it, and who was it? Bruno immediately said, "There's no way. You can't do it." He was almost telling me I couldn't do it because we were already building this thing from scratch. So for me, the thing that I would change would be just to scope it a little better and just bite the bullet and find some more resources. I tried to do it all myself for the mechanicals. It didn't work out as well as I would have liked it, so I think that's probably the lesson. Is sometimes it just takes a little perspective to step back for a minute and just, even if you're wasting a day or two, just scope out your work and just find somebody else to help you. Get more resources. That's the one thing I would have changed. And not lose my wife for 6 weeks. That's my wife back there with son, by the way.
Back to being
I
supportive.
think she likes you because she's here, right?
Back to being supportive, yeah.
Okay. Last question, and then before we open it up to the audience, I'll ask you all to sort of stand in front of your robot and sort of point it out so we can get it on camera and on video. And the last question, for anyone who wants to answer it, are robotics competitions a valid way to progress the state of the art?
100%.
Yeah.
Absolutely. First, think of what FIRST and Lego Robotics League and all those are doing for teaching kids how to do it. Robotics is coming from bottom up instead of from top down. Google put some money into robots and other people, but it's really all the thousands of kids who are making robots all the time.
The competition brought 18 people together from SV ROS that just wouldn't have come together to work on a project that we couldn't think of. And I've been homebrew and all this other clubs, and it's like hard to get that energy to do something and make something worthwhile. I know Wayne's tried to make a club bot a lot, and it just doesn't really take off or the way you expect. It's like our ROS thing we're trying to do. I don't know how it's probably going to flop, but we're going to try. But the challenges and the competitions make it so you all have a common purpose and you try to solve a difficult problem. I think it's the only way that robotics are really going to go to the next level. It's not because of the money. It's going to be because you've got a problem and you all want to solve it.
Yeah, I think one of the keys is it forces you to be around like-minded people. You have a common goal, and there's a deadline, and there's a beginning and ending to it, and you have a bunch of like-minded people that are forced to kind of come together and come up with a solution. And it's amazing what a group of people can come up with, as opposed to being an individual kind of noodling away at your own project. When you're together with a group, a lot more innovation happens. I think that's one way to drive it, and that's through competition.
Everything's awesome when you're part of a team.
That's right.
You can always blame somebody else, too.
That's right. The wheel of blame. We had the wheel of blame. Another topic that came up over and over. The wheel of blame.
Yeah, I have another group that it's the Up and Blue Smoke Award, which is the badge of honor. Okay, would you care to sort of point to the various features?
Have them pick them up.
Oh, yeah.
And me and Chuck.
I don't know. I can
So
wheel
I
it up.
can also
I don't know if that helps.
drive the camera, so.
I don't know if anyone can see this. But we were out playing with it.
Have it up on the video, too.
Okay. We were out showing what it is. And basically, we're using a Jetson as a single board computer, which is a $200 product from NVIDIA. And it's a 4-core ARM processor. And it's just a standard computer, if you ask me. We run Ubuntu. And pretty much the main piece is this RoboClaw 60 amp motor controller. And that's basically drives the motors and talks to the encoders, and it knows what's going on, where it is, and that talks back to the Jetson. The rest of it's all kind of superfluous. It's a wireless router, a USB hub, a circuit breaker, emergency stop in case it all starts going up in smoke. This is a camera system, a Raspberry Pi camera system with a pan tilt. But you don't need these things on your robot. Those are just extras. Basically, you need some sort of sensors to drive tell it where it is, and you've got the wheel odometry, which is enough. If you give it a plan, it can try to follow the plan. So, but when we had it in a competition, it had a lot more stuff on it. We had a big signaling system because you have to have lights on it, and we had a gantry with a claw that would pick things up. We had the RDF, which had a metal plate that was a pan for a hot water heater that was up at the top with little radio antennas on it, a whole bunch of other stuff. But this is really the core of what you need.
What kind of batteries?
That's probably the most expensive piece is a lithium ion battery that was like almost $800 with the charger, and so far I've never run out of juice. It's been running forever. Even the show day where we had it out, it was working for 6-7 hours. It still only took like 30 minutes to charge. When it's dead, it's supposed to take 2 hours. So it's like, it can run a long time. It's a good battery.
So, actually, I'm not going to pick it up like Greg did, but I'll power it up. Maybe it'll kind of show itself off a little bit.
People in the front row.
The people in the front row.
Watch your toes.
Like I said, big robots, you don't go near them.
So this is the basic configuration. Just a drivetrain.
How many horsepower is that, Chuck?
On each drive, so I have, these are 828-400 mag motors. They're each about 4.5 horsepower peak. Wow. I'm dropping about 120 amps into each one of those for up to 5 seconds, and then about 100 amps for, continuous. So, there's about 9 horsepower there. I run another 4.5 on the head. And through the gear reduction that I'm running on this, it's 192 to 1 or so coming out of this motor going up to the head. So that gives me about a 1 second lift time, which actually, when it's in this configuration, it's pretty good. The other configuration that I have is where it's actually called Predaraptor, and it actually has the big claw jaws on top. And it's a really effective robot. Because, if you grab somebody, it's got that much power behind it, you can actually pick them straight up and put them over your head. Which, the last match I had in that configuration was actually Sewer Snake, which was Stinger from the BattleBots show. So anyways, I'm running, just Robotech speed controllers. I got a Robotech on this head. This head can actually... I can drop 300 amps into this one right here. It stalls maybe a little bit more than that, but Whatever the case, that gives me all the power I could ever use, to get that, just that 1 second pop that I really need. Gear reduction on the drive system is 9-to-1. That gets me to about 25 miles an hour or so. I mean, it's a really fast robot, really unstable. If you've seen the show, you saw what it looks like. It's really squirrely to drive, although as long as I stay on the throttle and I don't try to tweak it, if I just hit the throttle all the time and drive it like a race car, it drives actually really smoothly. It's pretty nice. The alternative to that is to actually put a gyro on here, and I've used gyros before. Sometimes it works to my advantage. Sometimes if I don't have them tuned in right, it kind of kills some of my turning motion, because it'll help me drive straight, but the real advantage of this robot is to get in close, hit a corner of the opponent, and then turn into him real quick. And unfortunately, if you have a gyro on there, it won't let you do it. So I have to be able to turn the gyro on and off. If you look on YouTube, you can actually hear me say on some of the videos, turn the gyro off. Because I have the partner actually driving, my partner Chris drives the second, he drives the head, and then I focus strictly on the drive. And then just, he uses another channel to switch that on and off through a multiplexer. So there's, it's pretty straightforward. Doesn't have a TK1 on it. We actually were going to try doing some vision tracking. We had something working on like a little mock-up robot, but we decided not to take a chance with it for BattleBots because there was really just too much at stake, and we didn't want to try something new. But for the most part, it's pretty straightforward. As you've seen, most of the robots on BattleBots really aren't true robots. They're kind of just big glorified race cars with a couple extra channels.
In a big spinning, killing
A lot of
machine.
mass.
And a flamethrower.
Yeah,
A lot of mass.
and flame, and fire. Cool.
So this thing we call the Beast, Bruno named it the Beast at some point in the Git repository, and so it lives. The treads originally were, like Chuck said, they were on another BattleBot. In the tread themselves, there's a 90-degree, is that about it? 8-to-1 gear reduction, or is it 18-to-1?
Well, it was 2-to-1 off that right angle,
Yeah.
and then we were doing, I think it was 9-to-1. Yeah, it was about 18-to-1
Yeah, so it's
total.
a total of 18-to-1 geared there. And you're limited in the competition, in the SRRC competition, to 2 meters per second. We limit this to about 1 meter per second for various reasons. So there's 2 motors that drive the tread there. They're animatics smart motors that a previous generation, which was a bit of a challenge trying to find documentation and get them to work. In the head, this is what we call the manipulator. This guy drops all the way down to the ground, and there's another pair. Who did that? Did you do that? How did you do that? What do you mean? I have no idea what that just did, right?
Didn't you program that?
No, he did that. He put it in. He put it in autonomous mode for a short time, and it. Well, it's doing a thing right now. It's scary. There's 2 motors. Actually, that's one of our. If there is one thing that we would change, there's a whole list of them, of course. But if there's one, we would like to put both of the arms here on a single mechanism and have 1 motor. We have to keep these synchronized in the software because it can move independently a little bit. And if one of them drives independently, it's not a good thing. It's very ugly, and everybody freaks out and jumps and hits the red button.
Chuck fixes a whole bunch of stuff.
Chuck fixes broken metal in various places. Those are also animatic smart motors with a 50-to-1 inline gear reduction box. All this stuff is pretty expensive too. There's 2 Arduinos. One Arduino is interfaced to the radio control and drives the 2 wheel motors, and what else? Just that? And it runs the lights. The lights are a required element from the sample return challenge people. They want to know when it's in autonomous mode and when it's in pause mode. And the radio control is a requirement to be able to pause and unpause. It's part of the challenge, so for safety. So when the lights are solid, it's in pause, and we can see what they look like when it's autonomous. Somebody got the radio? And when you put it in autonomous mode, then they flash. Maybe. Or something reboots. All kinds of stuff goes. And we have the same NVIDIA boards. We have the TK1 boards. We have two of them. We have a master and a slave that are connected together through gigabit Ethernet. There's no end of tribulations trying to get those things to be synchronized in time and pass data back and forth. The TK1s have a USB 3, so we have two USB 3 hubs, and Hans back there did the mapping of USB devices to the various master and slave through the USB hubs, and all of the Linux configuration to get those devices to come up the same every time, because you have to be able to turn it off with this power switch, and the power switch actually disconnects the battery, so it cold boots the Linux boxes, and everything has to be synchronized when they come back up. So that's a challenge. The second Arduino over there controls all the manipulator functions. There's a total of 5 motors in the manipulator. The 2 arms, the 2 hands, which you haven't seen run. The hands come together, and then the tray motor, the tray moves out. The hands can only drop the samples here in the front. So to drop more samples than the front 3, they go into the back. The tray comes out, you drop the samples in, then the tray goes back in. There's another smart motor that controls the tray going back and forth. And so that's a total of 7 motors, 2 controllers. There's also a RoboClaw in there that controls these motors. There's a, what's that little guy called?
IMU?
There's an IMU there that has a gyro, tilt, and has a compass that we're not allowed to use. That's about it. 4 cameras. There's stereo cameras. These are PS3i cameras. Again, Hans put these all together. We went through a couple variations to get these to be focused straight, so once you calibrate them, they don't twist like this or twist like this. Calibration is very tricky. The final result was very good. This little camera here is an HD camera that's focusing on the sample as you detect it and you drive up to it and you go to pick it up. And then the top camera is focusing a little farther out. You can see the fiducial to tell where your base is, and you can see samples at a distance. And all this stuff is being done with OpenCV and ROS in the TK1s. And the TK1s, in theory, have 192 GPU cores each. So if OpenCV is compiled just right and all the stars are aligned, then you have 384 GPU cores, and from what I hear, we never really were able to get that all to work. So next year, assuming that the competition goes again, then I think that would be one of our goals, would be to get the image processing threaded to spread it out across the ARM cores, as well as get OpenCV to talk to the CUDA GPU core interface and be able to spread that processing out across all those, who knows how many, 384 processors.
Let's, now we're running a little late, so we can have like 10 minutes for questions. So, Joe?
Yeah, if you think about all the competitors, was there one area where most of the failure focused, or did everybody fail on something else?
I think from the point of view of the director of the competition,
Ken, yeah.
he was, his probably biggest regret is that mechanical was a big problem. Motor controllers, blue smoke, people not getting off the platform. You know, he really would have liked to see a lot more vision processing going on. I think that's kind of the thing. It's a hobbyist competition, like you said, mom and pop. And a lot of people just, you know, you have to make your own platform, and that's not a trivial thing to do.
Made it too big a task, huh?
But
yeah, it is a big job.
Above that, the teams that were doing level 2 stuff, they had a year
right, to figure out the vision. They showed up thinking they knew the vision, and it didn't work. Their stuff did not work. So it's like, oh, you know, what was that? Why did they not take the money? You know, why didn't they pick up some more samples? And I think it goes to a point where, you know, you kind of like have the freshman class who were mechanical, but the senior class was doing vision and should be able to pick this stuff up, and they didn't.
Steve?
Yeah, just one thing, I guess, from a kind of a contest perspective that I noticed. On the one hand, it's good that what I saw is everybody, including us, is approaching this from like sort of a general problem, like how do we go out and find random things in a huge area, which you said you didn't expect the samples to be that close. And having been through the competition, I thought about it afterwards, like, yeah, that makes sense that they would place them closer up front. Because you have so many robots to run through, you know, at a certain, you know, on one day or maybe 2 days at most. You're not going to put them, you know, from a kind of that logistics, you're not going to put them all the way, you know, in different range. They're going to be fairly close. They're going to be, you know, so what I saw and what we did also was everybody tried to tackle this as more of a general problem. Weren't really thinking of it so much as a contest. Like, you know, hey, we probably only have to search this area, you know, probably only have to do this. But on the other hand, I think it's kind of good that people were kind of more project or task focused, because that's actually really interesting stuff. Saw a lot of people with integration issues. Again, we had our own. We laughed last year and said it's not going to happen to us, and it did. I now have sympathy for every NASA launch I've ever watched, where the guy counts down 3, 2, 1, and the thing just sits there, and they're like, "We're having a hold now. We'll be back." Because I know somewhere in there is like there's some valve that somebody checked 100 times already that just.
When we were at Battle Bus, we were in the first day of viewing, and the way you could really tell it was going to get started, because there's a lot of, you know, the audience is there for the show, not the other way around.
Right.
And where you could really tell when it was going to start was when their drone took off. You know, because once the drone took off, they were ready to start filming. And so I told my daughter, like, you watch the drone. When the drone flies, it's going.
Yeah.
It's coming. Because otherwise you get all excited and then they go on a 10-minute break.
Yeah.
You know, and so the very last one, we were there at 5 o'clock, drone flies, everything's ready to go. And okay, thank you very much. Daytime people, you can leave now. Everybody else, we're going to have a new audience now. I'm like, wait a minute, run this one. Let's just see one more.
First off, I want to thank you three for speaking. I wanted to say I also competed in the NASA SR challenge as well. I know there's many late nights and a lot of funny moments from lack of sleep. What's one of your stories for the funniest moments working together that you can share with the audience?
So many.
Can we actually talk about
I mean, the wheel of blame was a constant source of entertainment. The other one that had us rolling is, while we were there, we invented, you know, Uber, when you put in your phone and you get a ride. Well, we invented Uber, which is you put in your phone and they bring you beer. That was pretty funny.
to stop building robots? Let's start.
There was I believe maybe 2 videos. Rath might be able to bust them out right now and show the 2 videos of everybody working and me sleeping.
Yeah, that was good with that too.
Yeah, that's
So, I mean, we went on Friday and we stayed at Henry's house in Rhode Island. All of us in the same house, sequestered for 3.5 days.
Well, at least we all had our own beds in that house.
Yeah.
So we went to, when we showed up at the event, we only had one.
We
room.
stayed in one dorm room.
One dorm room. It had separate rooms, but we had to hot bunk, so we had to swap.
There was a total of 4 beds and 6
for
people.
us to sleep, and we really didn't sleep that much anyways when we were there. So
What's it like, doing the robot thing with the screaming crowds, and it's like kind of a rock star kind of thing? How is it?
It was amazing. I have to admit, it was freaking amazing.
Chuck is a rock star, actually.
It was crazy. That was, yeah, that was a good moment for robots, and just to be a part of it it felt really good. I mean, they were, it was like going to a rock concert. Because we're walking up on stage and they're blasting Ghostbusters, right? Except it was Ghost Raptor, and it was just amazing all the coverage that went into it. I mean, you guys saw 5% of what the footage was. They shot footage after footage after footage.
2 days just of Chuck.
Yeah.
Well, they came, and they only took like 30 seconds of it, but they came, to Nito, filmed for 2 days. And then at the event, it was just like every time, it didn't matter whether you were in a match or not, they would just want to know where you're at, what are you doing, what's this, and they had, it was just
in your face.
A whole bunch of cameras, 4 or 5 people, grips, and production assistants, and the cameramen and everything else. It was like a real rock event. It was pretty amazing.
The production value was incredible.
Yeah, it was really well produced. I mean, the end product was great.
Yeah.
Looked like fun.
Yeah, I was lucky to be a part. It was good.
You gonna do it again?
I don't know. Where's my wife?
She stepped out.
She's not here. You can say yeah. I'm doing it again.
It is a video. Bill's got to turn off the camera. Right. Video live capturing forever.
So will you guys do the sample return challenge again next year?
Likely, very likely.
Very likely,
If they have us, it's likely we'll do it again.
Yeah.
It'll be interesting to see how the team folds out and how the robot changes. I think we had a retrospective, and I think we picked apart the robot to the point where the new robot will almost be a whole new robot. But we'll just have to see. It matters of time. We're not really going to put a lot of effort, I don't think, until it's confirmed, and then then it's going to be all hands on deck and trying to get back there.
The nice thing is we're starting with something, right? They have a platform that works. They can develop with it, and then in the meantime, while they're working on that,
In the meantime, you can do BattleBots again.
True. But no, we have some baseline to work off of, which before we really didn't have anything working until a month before the event. I think. I mean, it was like we were scrambling because you have to have that. A month before the event, you had to provide a report for them. They had to have a video, and you had to essentially show them you were a viable competitor. I don't know how much they were expecting to see, but they wanted to see something. So we didn't really have something that was picking up samples
Until that day.
30 days before it. So now at least they have something to work on for 4 months, and that's a big deal.
Take Joe, and one more question after Joe.
So, would you go so far as to build 2 of them?
Well,
It's a lot of work.
Yeah.
It's expensive too.
I think what would happen would be I would design it just to retrofit this piece by piece. I'd start with the same platform, build up on what I've already got, or what we've
And
already
meantime,
got.
we can drive this around. One of the key issues with this is that it's too slow to cover the whole field for level 2. If we were really thinking about picking up 10 samples and winning the whole prize, or if somebody else picks up 10 samples too, then you split the whole prize. So you really got to go for the whole pie. And to do that, it needs to be faster.
How much is it?
How much is
$1 million?
$1.3 million is left in the pie,
Kitty.
in the kitty.
What did it cost you?
All up, including flying and hotel stays and rental cars and stuff, about $15,000.
So the robot was maybe 8 to 10?
Yeah.
Some of that.
Yeah.
Nito was generous enough to cover our travel.
That's why there's Nito stickers on.
That is sweet.
Yeah. They got some good press out of it. While our robot was driving around the back of the bandstand, we didn't have anything to do, and I talked up about Nito, wall following, sensors, and stuff. We didn't have anything else to talk about. And some of the Nito folks, Nancy, who actually approved the money, she noticed.
Actually, your run actually looked like it was doing a little
Yeah,
wall follow.
yeah, it was perfect. It was a perfect, segue.
Okay, hey, thank you so much. We have to be out of here by 10 o'clock, but until then, we have open access. You can talk to other people or talk to our panel members. Thank you so much for coming. See you next month.